Hey, and welcome to Lesson 4A. Let's get started. In the previous assignment 4A, you studied some data from the American Cancer Society. You also read about using probability to better understand your risk. Probability, understanding risk. I want you to complete questions 1 and 2. After you hit pause, complete those, and then come back and work on the video information with me. So now that you're back, if you roll one die, a pair would be called dice, but one's just a die, what are the possible outcomes? And everything that we're going to look at and do in probability, I want you to have a pattern so that you are able to catch all of the possible events, possibilities, like when you roll a die, it can land on a 1. So I'm going to start at the smallest number it can be, and then you could roll it again. It could land on a 2 or a 3, etc. And these are the only possible outcomes. And we're not going to talk about it landing on its edge or corner. We're just going to go ahead and say it's going to land flat. So there are 6 outcomes. Similarly, if you flip one coin, what are its possible outcomes? Again, not that it's going to land on its edge, but it's going to have heads up or tails up. The objectives for this lesson include the concept of probability of independent events. You should have already started a glossary or flashcards or sticky notes or something. Here are another set of words that you need to start memorizing, the independent events. And then how probability can help us to understand the risk of different situations. In this lesson, we're going to calculate theoretical probability of 2 or more independent events. Also, we're going to calculate and or probabilities for independent events. So start getting your brain wrapped around. We're going to be calculating a thing called independent events or for independent events. Sometimes they'll be called and sometimes they'll be called or. Keep reading along with me as we further explain what's going on in the objectives. So, like right here, it says, according to probability theory, 2 events are considered independent if the occurrence of one does not affect the probability of the occurrence of the other. For example, if you do roll a die and you get a 6, this result does not affect the probability of getting a 6 or any other number on your next roll. It's not going to impact that. Probabilities may be determined when 2 or more events occur at the same time, like an event A and an event B, or when at least one of 2 or more events occur. In other words, event A happens or event B happens. So let's look at how the probability of independent and independent or events are computed. So start getting those areas in your brain to start filing some information about independent and independent or. And remember, you can start and stop this video as much as you want. You may want to let it play on a little bit to help the concept gel in your brain, but sometimes it's going to be good to hit pause and go back and simmer on, think on some of these concepts. So just like earlier, I want you to go ahead and stop the video, do question 3, and then come back and let's work on it together. If you roll one die, what is the probability of getting a 2? So we're going to start a little bit of notation here, probability of getting a 2. We're going to write this as a fraction, a ratio. The probability is going to include the numerator stating the event that we want to occur, that it happened or it's going to happen, out of the total number of events. We've had part and whole before, and so this is the event we want to happen. What's the probability we're going to see that, or how many outcomes can actually be that event over the total number of outcomes. So when you go to roll a die, what's the probability of getting a 2? Well, since there is only one side that has a 2, but yet there are 6 total sides, we say that the probability of getting a 2 on one roll is 1 out of 6. Similarly, we'll come over here and talk about the second one. If you flip one coin, what is the probability of getting the coin to land on heads? Again, we'll follow how many of the events are there that can happen, the outcomes, over how many total possibilities there are. Well, only one side of the coin is labeled heads, but yet there are two sides of the coin. So we call the probability of getting heads on one roll, one flip of the coin is 1 out of 2, 1/2, 0.5. We'll keep going. Go ahead and hit pause. Take some time to do questions 4 through 7, and then come back and we'll walk through them together. Starting at question 4, it says if you roll one die and flip one coin, does the occurrence of a particular outcome on the die affect, impact, change, cause a particular outcome on the coin? Why or why not? Well, the answer is no. Getting a particular number on the die does not affect whether we are going to get heads or tails on the coin. So go to question 5. If you roll one die and flip one coin, what are all the possible outcomes? So I've got a coin and a die happening at the same time. We're going to look for a pattern. So I'm going to start here with the die. And remember earlier how I said pattern starting with least, going to greatest. And then on the coin, pattern was, well, we've got one side or the other. So I'm going to start right here with 1 and work it all the way through. In other words, over here, I'm going to write everything down. I can end up with a 1 on the die and heads on the coin. I can end up with 1 on the die or tails on the coin. Well, I'm done with 1. Let's move on to 2. 1 is done. If I get a 2 on the die, that means I could be getting heads on the tails, heads on the coin. I could get a 2 on the die and I could get tails on the coin. Well, 2's done. So I'm going to keep going with this pattern until I go all the way through the possibilities on the die and the coin. So the question is saying, what are all the possible outcomes? I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes, and they are, as you see, right up here. It says another question, if you roll one die and flip one coin, okay, got it. What's the probability of rolling a 2 and flipping and seeing heads? I'm going to change colors because I'm going to go looking. I need 2, not a 2, not a 2. Uh-oh. This one has a 2, that one has a 2, not a 2, not a 2. Nobody else is rolling a 2 on the die. But the second part says, and landing on heads. There's my winner. If I have the combination of a 2 on the die and heads on the coin, that's what they're asking. But the probability is, how many times did you see it occur over here? Once. Out of 12 possible outcomes. Number 7, consider your answers to question 3 and to question 6. How are the answers to each of these 2 independent coin flipping and die rolling related to the probability of the events both occurring? So back on question 3, I believe it was, I better look. On question 3, it was asking, what's the probability of rolling a 2 on a die? And we said 1 out of 6. And then we said, well, what's the probability of getting heads on a coin? Well, 1 out of 2. So this is saying if those are your answers on question 3, and the answer on question 6 was, well, if you're going to take these independent events, 1 out of 6 and 1 out of 2, and we put them together and say, well, how many is that going to have? How many outcomes would that have? We end up with 1/12. What's the connection? If you take the probability of the first event times the probability of the second event and multiply them, 1 times 1 for the numerator, 6 times 2 for the denominator, you're going to find we got a little shortcut here. We can always write out all of the events. We can also always do the mathematics. Now go ahead, hit pause, and do questions 8, 9, and 10. When you've got those completed, come back and we'll walk through them together. This first part says, refer to the website of information from the American Cancer Society. Here's the website. And don't include that period. It'll really mess you up. Part A, if we randomly select 2 United States females, what is the risk that they both, we've got 2 here, and female, will develop breast cancer sometime during their lifetimes, and assume that these are independent events. And I want to go ahead and pause here to say that we're going to talk about a lot of sensitive topics this semester, cancer being one of those. So we are talking about the numbers with great respect that these numbers are attached to real people. So the numbers we're looking at, it says 2 females both develop breast cancer. And then, well, hang on, I'm jumping to B. Go back to right here. I want to remind you what we just did on the last question. We took the probability of the first event occurring, rolling a 1 or 2 on the die, the probability of the second event occurring, flipping heads on the coin, and the way we conducted this mathematics is that we multiplied those together. Another way to say that is the probability of event A times the probability of event B is what we found the probability for event A and event B happening. So in this case, the 2 events happening would be that 2 females would get breast cancer. So the probability that 1 female, according to the article, would get breast cancer is 1,232 10,000ths. So if that's the probability of a random female, it's also the probability of a second random female. The question is, what's the probability that female 1 and female 2 will both develop breast cancer sometime in their lifetime? And so up here, to calculate what is the probability of P and B, you take the probability of 1, multiply it times the probability of the second one. So the probability of event A happening is, and we're going to multiply it times the probability of event B, which is the same in this case, happening. Grab your scientific calculator, and we'll punch these in. And I get a number like, the number is longer, but when we get a number about like this, we're going to go ahead and convert this to percentage. And it doesn't tell us what to round it to. Let's round it to let's round it to the hundreds. The 7's going to make this. So the probability is about 1 in 5/200% chance that these 2 females or 2 random females are going to develop breast cancer sometime in their lifetime. We're going to keep going to part B. Is it possible that the choice of 2 females is not independent? That it's not just a random female and another random female? And if we think about it, it could be that it could be yes or no, and you write something down. But it is possible, and we use the word ish in class today. Yes, ish. It is possible if the females are related, like a mother and a daughter, they may have a genetic makeup that changes these odds to increase or decrease the outcome possibilities. So it is possible. On question 9, if you roll 1 die and flip 1 coin, what is the probability of rolling a 2, or flipping a head? Why? Okay, let's go back to where we were. Well, wait, before we do, I want to come back up here and point out, we have a formula. The probability of an event and another event occurring. Now remember, all that we're talking about right now are independent events. They're not impacting each other. I know we went yes-ish down here, but we're assuming random, independent. And our formula was if it's and, we're going to take the probability of one event and multiply it times the probability of the second event. We saw this happen earlier when we wrote out all of the possibilities of flipping a coin and getting heads and rolling the die and getting 2. We just found 1 out of 12 possibilities. Now it's a brand new question. A brand new question asking, if you roll one die and flip one coin, what is the possibility of rolling a 2 or flipping and getting heads? We are working on question 9, but I've gone back to this screen for questions 4, 5, 6, and 7, and I want to look at these parts. Let me find a color. I want to look at where we were when we wrote out all of the possibilities earlier. When we wrote them out earlier, it was an and. We had to have a 2 and heads. But this one's worded differently on question 9. It says, so you can get 2 or you can flip heads. Okay. Well, here's a possibility that has 2 and heads. But this one has a 2 but no heads. Well, that still counts because it says or. Well, let me search and see if there are more options like right here. This one's not a 2, but it landed on heads. This one's not a 2, but it landed on heads. When we throw in the word or, it changes a lot. So this one landed on heads, this one landed on heads, this one landed on heads. I think we've got them all. We've got every possible outcome where we could land on heads or roll a 2, and now we can count them. And when we count them, we have 1, 2, 3, 4, 5, 6, 7 possible outcomes out of a total 12 combinations. So now I'm back to this screen. And looking at this screen, the question we left at said, if you roll a die and flip a coin, what is going to be the probability of rolling a 2 or flipping it 2 heads? And we counted, we noticed, we looked at it, and there are 7 possible outcomes out of the 12 total outcomes where this occurs. But I bet if there was a formula up here for and, there's going to be a formula for or. The formula for or is a little bit more complicated. We're going to take the probability of the first event, we're going to add it to the probability of the second event, but then we're going to subtract their and probability. Let's go find all of this data throughout your in-class pages. The probability of A, and if you want to go ahead and put the probability of, and I probably should go ahead and write that in there, the probability of getting a 2, the probability of landing on heads, the probability of landing on a 2 and on heads, and that's going to ultimately get us the probability of a 2 or landing on heads. A little bit more complicated. Probability of one plus the probability of the other minus the probability of them as independent and events. So the probability of 2, a while back we noticed it was 1 out of 6. The probability of landing on heads, 1 out of 2. And then the probability of 2 and H, well, that was way back up here that it turned out to be 1 out of 12. So now we need to do some math on this. I'm going to go ahead and write down here on my 10s area, my question number 10 area. And to do the math, you've got to learn how to do some fractions. You got to learn how to add, subtract them. Later we're going to do some multiply where we just multiplied. And to do this, use something you've learned before, finding the common denominator. I'm going to go ahead and do a cheater. And the world of math may or may not like this, but for right now, we're going to do a cheater. The cheater says you can take these two, multiply, keep the symbol, and then multiply this direction. Put it over these two multiplied, which is 12. So that means I now have 8/12 minus 1/12. And when I finish this math, since I have a common denominator, I'm allowed to go ahead and say 8 minus 1 and keep it over the common denominator. And you'll notice that we found this 7/12 by counting what we had over there on questions 3 and 4, but we found this 7/12 mathematically. Both work every time. You need to be aware, familiar, know how to calculate and work with both ways. This again was writing out all the possible outcomes, counting up the ones that fit our criteria. This bottom one was calculating using probability of one event plus the probability of the second event minus the probability of the events as an and. So finally, we are on question 10. If you roll one die 2 times, let's go grab some other form of color over here. If you roll one die, 2 times, what is going to be the probability of getting a 2 on the first roll and a 2 on the second roll? So what's going to be the probability of getting, and this is where we've got to interpret, is this an and? Is it an or? Are these independent? Are they dependent? Well, the cool thing right now is we're only working with independent. So it's either going to be an independent and or an independent or. And in this case, it is saying that they want us to get and. They want us to get a probability of 2 on the first roll and a 2 on the second roll. When it's an and, it's not the one that we just did. The and was earlier. An and formula was take the probability of the first event, multiply it by the probability of the second event. And in this case, to get 2 on a die, it's 1 out of 6 times 1 out of 6. We're going to multiply straight across carefully, And how many possible outcomes would there be? 1 out of 36. A while ago, I said you can always write these down. Always may be too strong, but we can start playing with a few and it's going to get really messy. Remember the pattern. If I roll a 1, I can roll a 1 with a 1. If I roll a 1, I could roll the 1 with a 2. If I roll a 1, I could roll the 1 with a 3, the 1 with a 4, the 1 with a 5, and the 1 with a 6. Whew, I'm done with 1. So now let's roll a 2. If I roll a 2, the other die could be a 1. Or if I roll a 2, the other die could be a 2. Or if I roll a 2, it could be a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6. And what you notice is we get 6 possibilities, 6 possibilities, 6 for 3, 6 for 4. We're going to end up with 36 possible outcomes. But there is only one such outcome where you roll a 2 on the first die roll and a 2 on the second die. And this lesson is almost over, but it ends up with a summary. And these pieces of information, you may want to cut them out. You may want to take pictures. You may want to draw them, flashcards, whatever you want to do. You must memorize these pieces of information. The first one is independent and. All we talked about this lesson is independent. Independent and, it gives you a little bit of thought and then it gives you the formula. You need to be familiar with, memorize the formula, and even how we were manipulating the items to get such an answer. The second piece, independent or. A little bit of verbiage about that, but here's the formula. How do we get the probability of an event A or event B occurring? Probability of the first one plus the probability of the second one minus the probability of A and B occurring. This concludes our lesson 4A. You need to check your calendar to see if there are more lessons you need to do, and we'll see you eventually at the next lesson.